Hi, this is OCR 21st Century Science Physics P2, and this is lesson 1, which is about the electromagnetic spectrum. So the electromagnetic spectrum is a family of radiations with some similar properties and some vastly different properties. We normally arrange the EM spectrum in order of wavelength, and it can either be from longest wavelength to shortest or from shortest to highest. But the EM spectrum consists of radio waves, microwaves, infrared radiation, check your spelling, infra, visible, ultraviolet, X-rays, and on the end there, gamma. So this family of radiations, known as the EM spectrum, has a few things in common. First thing they have in common is they all travel at the same speed. They all travel at 300,000 kilometers per second. And the second thing that they have in common is that they are all vibrations of electrical and magnetic fields. So hence their name. So they're electromagnetic vibrations. And they are all transverse waves. So it means that the vibration of the electromagnetic fields is at right angles to the direction of travel. And we're going to have a little look at some of the properties of each part of the EM spectrum and how they're used. Now, up until now, we've dealt with the idea of energy travelling in waves, where a wave is a way of transferring energy without transferring matter. But in P2, we want to consider the other property of radiations, which is the idea that energy travels as tiny lumps known as photons. Now, a photon is a lump or a packet of energy, and different radiations have different amounts of energy in their photons, and we'll deal with that in a second. But we want to get away from the idea of thinking of these as waves, but thinking of them as travelling as tiny lumps of energy or photons of energy. So let's have a little look at the EM spectrum in more detail. So we have radio, micro, infrared, visible, UV, X-rays, and gamma. Now the order that I've written these in is as follows. At this end we have photons of the lowest energy. So the photons of radio waves are very low energy. And as we go through the EM spectrum, all the way up to gamma waves, we end up at gamma, which is the highest energy photons. Remember, photons are these lumps of energy or packets of energy. Remember, they all travel at the same speed. It's just that these photons will carry more energy than these, than these, than these, than these, than these. So, looking at some of the features here, firstly, we encounter this section of radiations, and these are known as ionizing radiations. Now, ionizing means that these radiations are capable of removing electrons from atoms or molecules. So they have got enough energy in their photons to remove electrons from an atom. So if you have an atom here with electron shells around the outside, then an incoming photon of ionizing radiation would have enough energy to collide with an atom and to eject that electron. And as that happens, the photon becomes absorbed. So the photon is pure energy. The electron requires energy to escape from the atom. And so if there's enough energy in the photon, then you will be able to enable an electron to escape. Now, none of these are capable of ionizing simply because the individual photons are not energetic enough to give this electron the energy it needs to escape. So ionizing means to remove electrons, and that turns atoms into ions. And an ion is simply the name given to an atom that's gained or lost electrons. In this case, it's lost an electron, and so it gains a charge. Electrons are negative, so if I lose a negative, then what I end up with is what's called a positive ion. Now, ions are much more reactive than atoms, so this process of ionizing can have dramatic effects on the properties of the atoms. If these atoms happen to be inside the DNA of a human being, then they are going to cause the possibility of the molecules of DNA behaving in a way that's unpredictable. So ionizing radiation can ionize by removing electrons, and if this happens to happen in the DNA of a human being, then that DNA could behave in a strange way. It could mutate, and therefore in this mutation could lead to the production of cancerous growth. So if DNA starts behaving oddly because it's been ionized, we get these mutations which can lead to cancer. So obviously we know that hopefully that ultraviolet light is something that comes from the sun and causes cancer, and therefore we use sunblocks to try and protect ourselves from the ionizing effects of this radiation. Now, the X-rays and the gamma rays also come from the sun, but fortunately the Earth is protected by an upper layer of the atmosphere called the ozone layer. So if this is the Earth, and this is the ozone layer, then the ozone layer, and ozone is made with 3 oxygens, it's called O3. The ozone layer is the layer which stops most of the UV, X-rays and gamma rays from actually reaching the surface of the Earth. So we have UV, we have X-rays, and we have gamma, all incident upon the ozone layer. And these ionizing radiations are prevented from reaching us by the ozone layer. Now, the way that this works essentially is that the ozone made of O3, when the gamma, UV or X-rays hit it, the ozone is broken up. So ozone gets broken up by these radiations, which requires energy. So the ozone layer is essentially like a sacrificial layer. As these incoming high energy photons hit it, the ozone breaks up. Later on, because it's a reversible reaction, then the ozone reforms again. But the act of breaking up means that these are effectively stopped or absorbed before they get through the ozone layer. So most of these are prevented from getting towards the Earth. And if the ozone layer wasn't there, then certainly I think human beings would have died out long ago, because we'd have been irradiated by all of these high energy ionizing radiations. Now, as you may be aware, there is a hole in the ozone layer above the Antarctic. And that is caused by human intervention. So we'll have a look at that on the next page. So this hole in the ozone has been caused by chlorofluorocarbons, or CFCs. Now, chlorofluorocarbons were used as a propellant gas in aerosols. So as well as the active ingredient, so the perfume or whatever you're spraying, is a gas in the aerosol which is used to push the contents out, so the propellant. And also CFCs are used as the coolant in refrigerators. Now, these two main uses that we have for CFCs have meant that large amounts of them, when we dump our fridges and every time we sprayed an aerosol, then the CFCs would go up into the atmosphere. Now the CFCs interact with the ozone in a way which breaks them down but it breaks them down in a non-reversible way. So it breaks ozone down permanently. So what we end up getting is the ozone layer starting to break down. Now that ozone hole was discovered by British Antarctic Survey when they were doing surveys in Antarctica, and so this led to global action on behalf of governments working together in order to ban CFCs. So CFCs, chlorofluorocarbons, are now banned, but they're not used as propellants in aerosols anymore. Refrigerators now have to be collected, and any CFCs used as the coolants safely removed by the company that built the refrigerator, in order that we don't release so many CFCs. And I think the ozone layer is therefore recovering to an extent, but that still that hole exists. And obviously the consequences for a hole in the ozone layer means that we're going to get much more UV, X-ray and gamma coming through that hole, which is going to lead to greater incidence of skin cancers. Now obviously Antarctica is not a very populated area, and therefore there aren't been a huge number of extra cases of skin cancer. But if the hole was over a more populous area, then obviously that could have a devastating effect in terms of the number of deaths from skin cancer. So, ozone hole caused by CFCs, which were once used as propellants in aerosols and coolants in refrigerators, now banned in aerosols, and any old refrigerators are now collected to ensure that the coolant does not escape into the atmosphere. Key thing here is the permanent breakdown of the ozone. So unlike the temporary breakdown we witnessed here, where it's broken up and then reforms, CFCs make the ozone permanently damaged. Okay, we'll have another look at some more of the EM spectrum in the next clip.